So we have this road that's getting you from this point A to B. And if you follow the road or path, it's like this. But I see this question everywhere. Why isn't the shortest distance used or made as the road? Now this is the same road on top view. It's clearer now how shorter it is and showing us how much less material you might use. Isn't that more logical, economical, and environmental? Hello ladies and gentlemen, this is Antoine and I will reply to this question once and for all. So first of all, you need to understand how roads are located and designed. We start by gathering the required information using highway survey methods. And then we go over the study. So the study starts with the existing information study, and then the reconnaissance survey, and after it the preliminary location survey, and finally the final location survey. Now I'll get to the components taken into consideration in the design study. Topography and road cross-section, economical, environmental, social and safety factors, the speed used to design geometric dimensions, design hourly volume of traffic and operating conditions of a road, and of course, what kind of road is it? Is this road urban or rural, principal or minor arterial, collector or local road, or others? Heavy vehicles on grades rising or falling sharply. Also note that the design standards of highway are dictated by the properties of a chosen vehicle model. And then the design of alignments. Firstly, vertical alignments. It consists of tangents connected by vertical curves. So obviously, the topography of the area has a big impact on the vertical alignment design. You have crest and sag curves. In crest curves, you have two types, one of where the tangents are of equal sign, and one for the opposites. Crest curves have one factor under consideration, that is the stopping side distance, which is minimum side distance required for a driver to stop his or her vehicle after seeing an obstacle in the road without colliding with it. That is a very interesting subject in transportation engineering. I will not go into that now, but it would be extremely interesting for future videos. Now sag curves, although they also have two types regarding tangent signs, but they have more factors to be taken into consideration. Overall form of the curve and simplifying its drivability, and the lowest point might be considered as a weakness for drainage, so this should be taken into account. And here stopping side distance should be the one provided by the headlight, because this problem is faced at night, which is logical from a curve with this form. And now horizontal alignments. They are tangents connected by horizontal curves. Roads just can't be sharply connected with random angles together. A smooth flow should be satisfied, and in order to do that we need to design a circular flow where we should find the radius of each circle. And depending on guess what? Of course, you guessed it, the stopping side distance. It should be unobstructed. There are four types of horizontal curves. Firstly, simple curve. Secondly, compound curve, consisting of two or more simple curves turning to the same direction, having a common tangent point. Thirdly, reversed curve, comprising of two simple curves, same tangent and different direction. Finally, transition curves, when two circles have significantly different radiuses. Of course, we can't speak about road design without mentioning earthwork. How can we estimate the cost to transfer soil in the area to prepare for road construction? Computing earthwork is extremely important and mainly included in not just one but two steps of the study. The civil engineer gets the volume measured in each cross-section at each different station, and in the end represents it in a 2D axis as volume versus stations to compute the payments. There are also other special facilities having unique design and affecting the road location and plans, like recreational and scenic routes, where the design speed should be low and it should be easy to drive in, so the driver could enjoy the view without disturbance. There's also connecting urban roads to local streets, right of way acquisition, coordination of the highway system with other transportation systems, sufficient design standards for pedestrians, and lastly, not to forget that bridges have many special provisions. All of the topics I mentioned in this video are incredibly broad, and I could specialize for each a video where I could be talking on and on about it due to their importance and usefulness in our life. Just looking on the site alone isn't enough to get the answer. You need to collect the data and perform the required analysis. But let's have a simple look and just think about what we already know about this site. This is situated as an entrance to the village and has great views. And also, judging from the classification of the rare buildings nearby and the overall scene, this could be a scenic route. Now, no data is given about right of way, but already there are trees in the proposed shortest distance path, which might make an environmental problem. Also, no topographical map is given, but from looking at the site, the profile section of the terrain might look like this, and hence making a grade that is difficult to build on functionally and economically, and not at all suitable for scenic routes. You might have seen a lot of under construction roads, and perhaps you hate it because it took forever to finish and let you deal with trafficy diversions. But what if I told you that projects do not need to be unnecessarily lengthy? If you might be interested in seeing how project managers solve this issue, I have a whole ever-growing playlist named Construction Companion on YouTube, where I also present a strong, fast and powerful project management style. Road construction isn't a direct path. It is governed by civil engineering theories and applications that would make the roads safer and easier to use with less impact on the environment and less expenditures.